In this example, we're going to use IntelliCubic to program an open cut. So this would be one that doesn't go all the way around the part. And you will see here in the model, we'll open the model file. There's a parasolid here. And we can see it has a part with a taper on the end, or for these slots. What we want to do is cut these slots in the part, but we don't want to go all the way around. So first step is let's raise it up because it's on 0, 0 is kind of on the center line of the part. So how high do I need to raise it? Hit feature recognition, contour extraction, and we see the part is 109.96 down. So I'm going to just copy that number. I need to raise it up. So we'll go back to the model page, place model, and in the Z value here, we're going to select that and paste in our 199.6 number in. And then that raises it up here. We're back at normal height. Okay, so next step is to, let me rotate this a little bit. Let me grab this here. Well, we need to be able to rotate this so we can see the front of the part, because it's kind of sideways on this. It's kind of orientated not quite right for being able to see what we need to see right now. So I'll shut that off, the rotation button right here. And we're going to go to feature recognition, contour extraction. We see now our table of program is up at top and table of next is at 0, 0. So that's how we want to see it at the wire machine, because it's bottom of the part's going to be on the work table, so we're going to leave it there. Now for our extract patterns, we're going to pick open left. You can use open right or open left, depending on which side you want to start at. If I want to start on this side here, this will be the left side of the part. And I want to cut across with the wire to the left if I cut across. If I want to start over on the right side of the part and cut across this way, then I'm going to pick open right. So I'll pick open left, and before I pick my faces, I'm going to pick, well, before I forget, I'm going to set the option. So it's very important we go into this option button right here. And when you do an open shape, you need to use this start point extension, surface extension. And what that will do is on the first and last element, it extends them away from the part. We cannot start with it like right on the end, right at the wire coming directly at the corner. It has to be extended off the corner. So I'll just move it a ½ inch out. Use whatever number. You can play with this number. Maybe a ½ inch is too far, but I'm using a big number so we see the results. You probably only need to put 100 thousandths in there. Okay, so we're on open left. My start face, I'm going to click in start face. I'm going to click on this first face that I want to cut, this one here. Turns green. That's the first face I want the wire to see. Now I'm going to click on the end face, which is this one way here at the other end. I want to click that one, it turns green. And now it says mid face. That's my next prompt. So it's 3 clicks. The mid face can be kind of anything in between the first and last element. So I'm going to just randomly click one of these faces that's in between. Then you hit the extract button. Okay, and here's our contour extracted. It found all the faces from the first face to the last face. It found all the elements in between. I'm extended off a ½ inch on the 2 sides. Okay, so now I'm going to put back in a top view, and I need a wire start point out here on the left. So I'm going to go 2D drawing, starting hole, and I need one at, see the coordinates down here at the bottom? I'm watching these numbers. You might know exactly where to put it. I'm kind of just gonna find a good spot for it. Here's your X and Y wherever the mouse happens to be, down in the bottom right. So I'm gonna just hover the mouse out here somewhere near the end point. That's X minus 2.45. So I'm gonna go X minus 2.45 and Y up like a half inch just so we can see it. Doesn't really need to be, you know, your lead in line to your approach face line doesn't need to be so far away, but you could put in 10,000ths or something here, that would be fine. So I just used a big number so we can see it. So we got our start hole here. Let me click the contour again. So you have your contour here and the start hole. Now the start hole has to be perpendicular to this contour. It can't be parallel with it. You have to have a Y, like I put in a Y number. If I had just put it at X minus 3 inches, Y 0, it won't work. IQ requires the start hole to be perpendicular to the face that you're going to approach onto, which is the first element in the feature recognition, okay? So next step now, we got our start hole in, is to go to machining path here at the bottom. Path generation. We've got our contour. We only have one here, so we don't have to pick anything off of this list here. We only have the one that we made. And we're going to hit generate path. You would pick your cutting conditions. Now this could be different from each machine. I don't know what machine happens to be looking at right now, but I'm going to just pick a 1 pass cutting condition here. If you want more passes, you can pick 1, 2, or 3. Output your corner controls if you want to use your corner controls, and pick your number of passes appropriately because it'll write the program for that. And taper, we're going to retrieve from the contour because it's 4-axis. We need to do that. Our stop distance, this is going to be your residual, is your stop distance. So let's put that at 600 thousandths because my lead off is so long. And let's just leave this stuff alone. I'm at tangent, perpendicular. This should be for the exit move. So it should be, you're going to get a little move at the end. So that's what this is defining right here. So I'm just going to leave it on these settings for now and see what we get. Click OK. Bottom left, it says specify the start hole. So it's asking me to click on the start hole. You come over here, you click on the start hole, changes red, doesn't matter where you click, just anywhere while it's red, and boom, you got it. So let's do a top view. Okay, there's our tool path coming through the part, and our little tangent exit move over here. There's that little exit move off the part that the machining path was describing. That tangent perpendicular thing was right here. And that's basically it. Go to NC conversion, convert to NC, type a name for the NC file. 30 characters, I think you can go up to 30 characters here. Convert parameters, you might want to view in here about your stop codes if you want to use them or not. I like outputting in a single coordinate system. And if you want your M00, so you got some options in here if you want your M00s or not. And make your choices and click OK. And then when you have your name in there, just hit the convert button. So that made a program for us, which should have, let me just save the part just so I can have a junk 1, I'll call it, just so if I want to resume back where I am right now, because I got to shut this off. I'm on my PC, it's not at the machine, so once you have done this step on the machine, you're going to just hit the edit button, and whatever the file name you use should be sitting in the editor on the machine. So I'm at the PC, so I'm going to exit out of here, go to my folder, and the NC files, and here it is, test 1, and this will be the NC program that it just made. But if you're at the machine, like I said, just hit the edit button and it should have dumped it into the memory of the machine, and you should be able to graph it right from there.